Anthony Waititu Gishuhi. He's the chairperson of the Department of Statistics and Actuarial Sciences and also the acting dean, School of Mathematics and Physical Sciences. Now, Professor is joining me in a while, but today the biggest figure that we've been speaking about is what I like to use the flat figures, 140,000, right? So we want to see how the 140,000 was obtained tonight by Cherera and the rest of the commissioners. Now, this is a figure tonight out of the 14 million who voted in this election. And just let me use the flat figures, not the 200,000 that's on top. So is it possible that we can arrive to the figure of 140,000? Well, I want to try that first and see if it's possible to arrive at this figure. If it's possible, if it's not possible, then I'm going to call Professor to also try and arrive at that figure. But first, I will try it myself. Right. So that's it. So let's assume that 0.01% of the votes, that's over 100 times the 14 million. And here again, we are using flat figures. I would have opted to do the 200 on top, but it's impossible. So even in this, if we just cancel these zeros, even this one, we put it over 100, we will still cancel it. So this is what we end up having tonight at 1,400. Assuming I use that figure, but still, I could also use other figures tonight. Let me try 0.1% and see where it leads me to if I can achieve the 140. So again, let me try with 0.1 over 100 again times 14 million, the flat figure. I don't want to add the other one. So let me see if I get it again. We cancel that. This is over 10. Again, we cancel 0. It comes to 14,000. Right? So if I use 0.01, it comes to 1,400. If I use 0.1, it comes to 14,000. All right. Now, I guess it's not adding up for me, but perhaps there's a way it adds up that I don't know. So I'm going to call Professor Gishuhi. He's a professor of mathematics, acting dean at J. Quart of Mathematics. Professor, just come. So I want you, the figure that the IEBC talks about, just come a little closer to the screen. The figure that the IEBC talks about, the 4 renegade commissioners, is 140,000. Forget about the other two. So let's just do that calculation. Do that calculation. Try and get to 140,000.
For
just a little bigger, but it's okay. You can just go on. Yes.
So that should be then 0.1.
Yeah, 0.1. Yes.
Percent.
Yeah.
Of 14 million.
14 million.
Yes.
Yeah. A flat figure again. We're just using a flat figure.
Yes.
Yeah.
So as you said, you knock off that, you knock off that.
Yeah.
Then this is 1
That's 1 over 10, still 1 0.
That gives you 1,400.
No, this is 14. This is 14,000.
Yes, 14,000. Sorry. Yes.
Yes.
Sorry for that.
Yeah.
It gives you
14,000.
Yes, 14,000.
Yeah.
So this one went out.
Yeah, we went out with that.
So
yes.
this is 14,000.
14,000.
You're right.
Yeah. So assuming that we're using 0.1%, because the argument has been 100.01. So assuming, let me just reset the screen. Assuming again that now we use the 0.01 instead of 0.1, right? Let me just do that. Set that for you once more. Let me just do it for you. 1, 2, 3, 4, 5, 6. Let me just do it. Okay, so assuming now, let's use the 0.01 because it was 100.01.
Yes.
Just let's assume if we can arrive at that.
0.01% of 14 million. Again, as you put it, you knock that one out. Then these are 2
over 100,
again.
Yes. So you knock 2.
You knock 2.
Yeah. It's still.
So that gives you now
1,400 again.
1,400.
1,400.
So yes.
1,400 again.
Yes.
Prof, I want to do a calculation here.
Yes.
I want to do a calculation. You tell me if I am right. I like to do a reverse calculation.
Yes.
Let's just see if this one will work or if it won't work. Then you explain to me why. So let's assume that 0.01, this is 100.01, right?
Yeah.
Times, all right, not times, but I'll just do this one more time because I need to get this right. My mathematics teacher is watching somewhere. So let me try and get it one more time. So let's assume, right, that 100%
Yes.
of the votes, flat figure again, that's a rider, flat figure is equals to 14 million. Let's forget about the ones on top, right? For now, 14 million, right?
Yeah.
So let's take that percentage, which they are saying it's above what was supposed to be declared. So 100% is that. So if we did this, what about 0.01? Right? What will it be equal to, right? So we do this, 14 million, right?
Yeah.
14 million, 0.1 times 14 million, right?
Yeah.
0.01 times
that.
14 million over 100, right?
100, yes.
Over 100.
Yeah.
We knock this off again, right?
Then
This
over
will be over 100. We knock off another one.
Yes.
It still comes to 1,400.
400. Yes.
So there's no possible. Those are three calculations according to you. 1,000. Okay, 1,400, right?
Yeah.
So there's no possible way in those three calculations we can get to this. However, one more time, I want you now to do a reverse. I want you as the professor of mathematics now to look at a possible way in less than 2 minutes. Prof, work reverse from what we know the figures 142,000. How we can get back to that percentage, if you will.
So again, allow me to work with a flat figure of 140,000.
Yeah, 140,000, yes.
So then, sorry, that would be 0.01 percent of something we don't know, which is what you want me to look for.
Yes.
Gives you 140,000. I guess that's what we are looking for.
Yes, that's
so
what
we are looking for the number of votes, cast, the valid ones.
Invalid here,
yeah,
yes,
this
exactly.
X is the number of valid votes.
Yes.
Good. So simple maths.
Get us X.
So X.
And the X is not my X.
Would be 140,000.
140,000.
Times 100. Then you divide by 0.01.
To get X.
Yes,
to get X. Yes. Okay.
This one, simple math, gives you 1.4 billion.
1.4 billion.
Yes. Because these are how many zeros? You see, these are 1, 2, 3, 4, 5, 6. Then you'll be adding other two. Yes.
So we would have voted
1.4 billion votes should have been cast.
Prof, how?
The valid ones.
Okay. In 30 seconds, my director is on my neck.
Yeah.
The last trial here.
Yeah.
Tell us now how possible they reached this figure. Just tell us how possible they reached the 140 now. Don't work reverse, just tell us in your mind. Professor of mathematics, yes.
Of course, it's an error. I would say it's an error. The one who was working it out thought it's 1%. As we just...
If you work on 1%, it comes to that figure exactly.
Yes, it comes to that figure.
So 1% of 14 million.
Let's see.
Yeah.
We need to confirm. 1% of, no, I don't think so, 14 million. Again, we show the viewers. Again, we're just knocking out these two.
Yeah. It comes to 140,000.
Yes.
So that is the only possible way of getting to 140,000.
Yes.
If there was 1% vote ahead.
Yes.
So that would be essentially 100.1. Is it? Or 101%?
No.
Actually, 101%.
There should have been a difference of 101.
101%.
Yes,
that is the only way to get to 140.
Yes, 101%.
All right. Yeah. So in your analysis,
it's an error, and it should be corrected.
It's an error. It should be corrected.
All
right. If you have a better way of calculating this, please let us know. Professor here is a professor of actuarial science, and he's also an acting dean mathematics and physical sciences at JKU. By the way, my sister Very was in that school and she did very well. Second class upper, right? Thank you so much. Professor is leaving now, but my colleague Eric Latif and lawyer Charles Kanjama are next with the discussion when we come back. For now, let's take this short break. We'll be right back with them.